Hi, I am Muhammad Fazrul Harudin, and I am from Group 3. So our group consists of 6 people, and in this slideshow, we are going to present the proposed foundation for the project and health facility at IKBN Kuala Langat, Selangor. First of all, we are from Johan Engineering, and our company as a specialist in foundation design, and this is our mission and vision of our company to become the chosen option of client by achieving excellence in quality and timely completion of value-added projects, and to become the top construction firm by continually graduating worldwide standards and providing great customer satisfaction. So this is our mission and mission to ensure our work satisfy our clients.
Hi, Assalamualaikum and good morning. So my name is Siti Nurhashani binti Muhammad Salim, and I'm going to present to you the introduction for our group project. So the foundation are the lowest component of a structure because it supports before it is relocated to the earth underneath it by bearing the entire weight of the structure. So construction of the foundation is crucial to avoid any settlement or other movement that can harm any section of the building. It also can help to increase the stability of the building by preventing the tilting and overturning brought on by the earthquakes, winds, and an unequal distribution of living load. A deep foundation is a type of foundation that is used to support the structures that have a large load or are situated on soft or unstable soil, and it is also designed to transfer the load of the structure to a deeper and more stable layer of soil or rock beneath the surface. And deep foundation are particularly convenient for building high-rise building because they allow for the construction of tall and heavy structure on soft or unstable soil.
Assalamualaikum and hi, my name is Urus Ashira Atasha binti Adi. My metric number is AF19012 and I'm going to explain about company information. So, our company name is Johan Engineering Sdn Bhd and types of business that we do is construction. The registration is based on the Board of Engineers of Malaysia and the address is Prime Building, Jalan Yuk Syuk Din, 46050 Petaling Jaya, Selangor, and the website is johanengineering.com.my. Now, I'm going to explain about scope of our project. The scope of our project is these reports represent the design of foundation for the design of water tank, which is 100 ton at IKBN Kuala Langat, Selangor. So the design of foundations is including the design of deep foundation. For the designing of foundation, it also involves the cohesive soil at 10 meter depth of soft soil for this project. It is also includes the very soft soil pipe. So the main aim for the designing of foundation for this project is to determine the types of the foundation that we want to use based on the border report. Besides that, the suitability of foundation for this project is also important to prevent any unpredictable settlement of the structure and to provide stability for the structure. Therefore, a proper calculation is also required to measure the foundation that required a less cost but can support the building even when there are changes at the ground part.
Assalamualaikum. My name is Siti Nur Sakina binti Ramlan, metric number AF190211. Next, for the description of project, this is a site for the project of health facility at IKBN Kuala Langat, Selangor. The proposed site is only 5 minutes away drive from Polytechnic Banting and only 4 minutes drive from Taman Sri Putra, Kampung Pulau Arias, Taman Delima, Taman Sri and Taman Morib. The proposed location is 7 minutes away from College Matrikulasi Selangor. IKBN Kuala Langat, Selangor is also located at the centre of Banting and easily accessible by roadways. For the company organisation, we have several positions, which is Project Director, Muhammad Fazrul Amin, Project Manager, Azaria Batrisha, Architect, Siti Nohari Shahani, Structural Engineer, Ros Ashira Atasha, Site Engineer, Nur Iziani, and also Geologist, Siti Nur Sakinah.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Iziani Binti. I will present my part which is soil investigation. For soil investigation, there are 3 groups of loading that will be calculated in this project. Group A, the load from column is between 300 to 700 kilonewton, and for Group B, the load is between 701 to 1000 kilonewton, and lastly, for Group C, the load from column is between 1001 to 2000 kilonewton. For the calculation, Fazrul will calculate the load from Group A, Rose will calculate the load from Group B, while Hani, Sakina, Izian, and Azaria will calculate the load from Group C. We highlight Group C because the load from the column at this group is higher. This is the depth of soil in this project. Fazrul will calculate the foundation at depth 3 meters, Rose will calculate at 4.5 meters, Hani will calculate at 7.5 meters, while Azaria will calculate the foundation at 10.5 meters, Sakina will calculate at 13.5 meters, and lastly Izian will calculate at 30.5 meters.
Assalamualaikum, my name is Azaria Batrisha binti Muhammad Hamdan with metric number AF190148. I will be explaining about our structural layout. As you can see from the figure here, this is our pipe footing, key plan, and then this layout is taken from SM software for our water tank design. And then for the next page is our pile foundation key plan, and then this layout is also taken from the SM software. For the water tank building, our design is created by using the SM software, and then as you can see from the figure, this is our design for water tank building for our group project.
For the design calculation part, I calculate for pile 450 mm times 450 mm. Loading need to design is 1208.7 kilonewton and length of pile is 13.5 meter. I got the N60 of approximately 6 meter, and then I continue calculate for the value of QP, QU and QS. And then I go for design of group 5 where I need to calculate the LG, VG, QG and also Q allowable. The Q allowable is 1632.96. And last step, I calculate for the elastic settlement of pile by using method of Paulus and Davis until I got the last settlement value is 38.36 millimeter, less than 65 millimeter, which is okay.
So now I'm going to explain about our pipe for design calculations. So for my pipe for manual calculation is I use column P5 C23 and the diameter of my pipe is 1600 and I use octagon shape and the depth is 39 meter, which is wrong, but I already do some correction at the appendices. And the loading that need to be designed by me is 804.1 kilonewton, which is for Q all that I get from the manual calculation is 3231.21 kilonewton, which is bigger than 804.1 kilonewton, which means that the design is okay. So for the settlement calculation that I get is 43.23 mm, which is less than 65 mm. So the maximum permissible settlement for clay source is 65 mm. So that means the design is okay.
Here is the foundation design made by me, and for my design, I will design for column number 12 with the total of 694.9 kilonewton. The parameters such as depth is 3 meter, the pile diameter that will be designed is 150 mm, and the soil type is unconsolidated, which is gravel, and shape is square. Spacing of the pile is 375 mm, and factor of safety is 3. So from the design, I obtained the result, which is the type of pile used is group of pile. Since it cannot sustain with a single pile, group of pile will be used. Then the number of pile is 9, and the allowable Q is 1246 kilonewton, which is more than the load which is required. And the settlement is 45.58 mm, which is less than the required value of 50 mm. So the allowable Q is acceptable, and the settlement is also acceptable.
For the design calculation part, I calculate the pile with diameter 500 times 500 millimeter. Loading need to design is 1540.6 kilonewton and the length of pile is 30.5 meter. I got the N60 equal to 5 and then I continue calculate for volume of QP and QS. Then the QU is equal to 366.67 kilonewton, which is less than load that I need to design. So that I go for design of group pile where I need to calculate LG, BG and QG. And lastly, I get the QL of group pi is equal to 2024 kilonewton, which is more than 1540.6 kilonewton. And last step, I calculate the elastic settlement of pi by using method of Paulus and Davis until I got the last settlement is 29 millimeter less than 65 millimeter, which is okay.
So this is the manual calculation for design of water tank tower at IKBN Kuala Langat. We are using SPT method, and this is the step on how to determine the elastic settlement for this project. And the elastic settlement must be less than 65 millimeter. And for my elastic settlement, I cut 30.56 millimeter. And the maximum permissible settlement for clayey soil is 65 millimeter. For the next part is the calculation for pile foundation P9/C14. The first step is we will be using the SPT, and then the diameter is 2000 millimeter, and then the shape is round or circle, length is 39 meter, and as you can see the QP is 1287.4 kilonewton, and then I will be calculating QS by using alpha method. As from the calculation, you can see that the QS is 709.4 kilonewton, and the QU is QP plus QS, which is 1996.8 kilonewton. And then for the QO, QU divided by FOS, which is 6656, which are larger than 1883.5 kilonewton. So the QO is acceptable. And then for the next part is to calculate the settlement. We will be needed QWP, QWS. So for settlement 1, the value from this calculation is 2.78 millimeter, and then for the second settlement is 7.97 millimeter, and then for settlement 3 is 3.79 exponent negative 3 millimeter. So the total elastic settlement is 10.8 millimeter, which is acceptable for clay. So for the summary of design for this project, we have 6 different type of group, which is Group A, Group B, Group C, Group D, Group E, and F. And all group have different loading from column, different diameter pile, and also different shape of pile. So from the manual calculation for each type of foundation, deep foundation are used for this project, since each of the group are able to carry the bearing capacity and overcome the settlement of the foundation. And different settlement poses a direct threat to the integrity and capacity of a structure. And this uneven settlement of the ground could result from many activities, including the changes in moisture content, the vibration, and the nearby construction activities. And in this project, on every type of different shape and diameter, the settlement value is okay because it is less than 65 mm in terms of the settlement from the manual calculation. And we must be less than 65 mm because it is built on soft soil, and less than 65 mm of settlement value is the condition that we need to follow. So that's all for our group project.
So the last one is I'm going to explain about conclusions of our project. As we all know, the foundation is a significant part of a structure that helps to transmit the loads from the structure to the underlying soil or rock. So in the design of foundation, the transmission of the structure load to the soil stratum with an adequate strength is very vital. Besides that, the reduction of the bearing pressure by the spread of the load over a sufficiently large area of the stratum is important as well in the design of foundation. In this project, analysis for deep foundation is made. Furthermore, soil properties from the bore are also being analyzed in this project. From the manual calculations also, our group able to carry the bearing capacity and overcome the settlement. The improvement of soil condition can also eliminate the need for the costly deep foundation. And as a conclusion, the objective of this study are achieved.